in my view, is one of the most easiest topic out there if your basics are right. Okay. If your basics are right, then doing binary search in an interview is would be a cakewalk for you. Okay. So fair enough. Let's just start off. Is everyone on the same page? Yep, I think so. Everyone is on the same page. Let's just start off. Let's have a quick revision of out there. So just a sec, let me just share my screen. Okay, my screen should be visible now at this point. Just a sec, let me just pin myself. Yep. Okay. One of your device isn't unmuted. Which device? Let me just see. One of my devices. No, no devices are unmuted. No, it's fine. Absolutely fine. Yep, my audio is on unmute. Okay, fair enough. So let's just start off at this point and let's just see what it has to offer. Okay, so let's just start off. So we learned about what is data structures and algorithms. Okay, so I would repeat the same example again. So let's talk about data structures and algorithms. So algorithms are nothing but way to solve a problem. This is algorithm. What are data structures and why do we need data structures in the first place? We need a data structure to complement the algorithm. What do I mean by that? Let's say I would take a very simple example in next just 2 or 3 minutes, that you can drink water from a glass also, from a bowl also, as well as from a plate also. But the ease of drinking water from a glass is more than drinking water in a plate. In the same manner, let's say you want to access the last element, you can access the last element, pop the last element in an array also, but doing that in an array, doing that in a stack is very easy. That is why they to algorithms are way to solve a problem, and data structures are nothing but containers that support the algorithm. That's pretty much. Then we learned about what is array. Array is nothing but a fixed size data structure out there. Okay, what do I mean by fixed size data structure out there? Like, let's say I have a routine out there. Like at 1 p.m. I would be taking your class. At 2 p.m. I would be taking an offline class. After 5, I would be going on to a ride. From 5 to 6, I would go on to a bike ride. I bought a new helmet out there of Exor, and it looks crazy. To be honest, I after a long period of time, I invested my money over a helmet, and it looks crazy. The full black one, matte one. It's good one, Exor Apex. It's good one. So I would go on a bike ride. Then after coming from a bike ride, I would cook my dinner. My friends would be coming in, so we would be chit chatting and all. So there is no place out there to accommodate a new event in today. I have no place. So in the same manner, and each task is on after one after each other. Okay, you can just ask me, say that's what you would be doing at 5 p.m. I would be saying, okay, 5 p.m. I would be there. In the same manner, array is a data structure. Just a sec. Yep. Array is a data structure which has a fixed size and it can't accommodate new elements. It is contiguous in nature. Okay, it is stored contiguous in the memory. That's pretty much the idea. We can roam about in the array by using indexes. Array indexing starts from 0 and ends at n minus 1. Okay, 0 based indexes. If the size of the array is 5, then the indexes would be 0, 1, 2, 3, 4. Now, this was the thing. We did some problems of sum of an array, find the Fibonacci number, find if all the digits in an array are, they were like reversible palindrome or not. Then we other sum of an array. These all things I did. So that's pretty much what we talked about. Can I have a quick one in the chat if I'm clear till this point? Just this. Anyone has any confusion, you can ask me. Else we can just pretty move forward. So I missed the first class. Okay, fair enough. So would keep this like a discussion, not like a lecture. Otherwise, you would lose interest. So in the meantime, we would just talk about a bit and then just go here and there. Okay, like these all things. Okay, fair enough. Done. So now let's take a very simple example. I don't really need to share my screen. Okay, just understand this. Okay, let's say what is happening is, let's say you all are here in my class. Okay, I got a call from my friend. Let's say I got a call from my friend Siddharth. Do one thing, there is some Nitesh in your class who is my friend. He has some doubts, kindly cater it in the class itself. Okay, there is a person named as Nitesh. I need to locate him and clear his doubts. Am I clear with this problem statement? Very simple. Now, the very first thing what I can do is I can go over to the participant list. I would just show my screen also. What I would do is I would go over to this participant screen. I would go over to this participant screen and one by one check if any person is there with the name Nitish or not. If I scroll to the very bottom and I don't find Nitesh out there, I would say he is not present. Okay, I would go over each children one by one and see if Nitesh is present or not. If I went till the last and I don't find any person named as Nitesh, I would tell him that Nitesh is not present. So basically, this is linear search, okay, where we linearly iterate over all the elements one by one, and we say if that element is present or not. Okay, I would be writing the pseudo code of it also. So basically, if now just we need to just go out of this DS real life thing and then come back to this DSA thing. And now basically, let's say the if this is the array. This is the array. The array indexing would be 0, 1, 2, 3, 4, 5, and 6. Let's say the elements are 2, 3, 1, 7, 6, 10, and 13. Now, the problem statement is to know if the element 14 is present or not. So I go over to this element, go over to this element, iterate over all of the elements one by one, and check if the element 14 is present. If I go till the very end, then I didn't find it. So basically, what I can do is like to iterate over all of the elements, what I can do is I can simply have a for loop for int I is equals to 0, because the array indexing starts from 0 and the size of this array is 7. So I would go till the value of 6. So while I is less than n is here 7, which is equal to n, and I plus plus. So if I find any element, if a of I, if at any point a of I is equal to x is basically the element given which needs to be searched. If I find the element, I would print the index. If I come here, okay, and I return also from this point. If I come till this point, I would say that the element is not present. I would print -1. Okay, this is the code itself. Now, what is the time complexity of the code? If we talk about the big O, what is big O? Big O is the worst time complexity. In the worst scenario, we would go to the very last element and it would be still not present. So in the worst scenario, we need to iterate over all of the elements. That is big O of n. What is the best case scenario? That the very first I am trying to search Siddharth, I am trying to search 2 and it is the very first element. So the best case scenario would be 1. One operation, that the first element that we check is the element that we need to do. And in the worst scenario, we would iterate over all the elements. And what is this? This is none other than linear search. So this was all about linear search in 5 minutes. Okay. Am I clear with the intuition? Am I clear with the code? Am I clear with the time complexity? Am I clear with what it is and why it is needed? To search elements, why it is needed? It is needed to search elements. How we can search? We iterate over all of the elements one by one. To iterate over all of the elements one by one, we use a for loop and we go from 0 till the value of n-1. If we find any element that is the desired element, we print that index or do whatever with that and we return from that. If we come and if the control of the program reaches here, that means it didn't hit the if condition. If condition was a hit, then it would have returned. So that's pretty much the idea. Translating the same in Hindi in a very concise manner would be, लीनियर सर्च कुछ भी नहीं है. जब हमें एलिमेंट ढूंढना रहता है तो हम क्या करते हैं, हर एलिमेंट पे एक एक बार करके जाते हैं और एक एक बार करके जाने के लिए हम फॉर लूप यूज कर सकते हैं। एंड इन द वर्स्ट सिनेरियो में क्या हो सकता है, वो एलिमेंट प्रेजेंट ही नहीं है और हम सारे एलिमेंट्स पे एक एक बार गए। कितने एलिमेंट्स हो सकते हैं, n एलिमेंट्स हो सकते हैं, तो वर्स्ट के टाइम कॉम्प्लेक्सिटी बी ऑफ n है। एम आई क्लियर विद दिस? गिव मी अ क्विक वन इन द चैट। Anyone has any confusion? No confusions up till this point? Do I so quickly give me a rating based on 10. I would know if your rating is below 6, just let me know. Do I need to increase the pace, decrease the pace? What is the scenario? Quickly give me a rating from 1 to 10. Quickly give me a rating from 1 to 10. So only thing, you're too fast. Yep, because this is a binary search class. Okay, this is a binary search class. So the speed of the revision and the linear search is fast. But now I would be doing binary search, which would be slow. Done? Let's start. Now we are on the class itself. Now this is the official class. Okay, now see, I would tell you a very simple problem statement. Okay, if I go to this, if you ignore this element, if you ignore this person, because this is the organizer host, because so Zoom has a facility that the host is the very first participant out there. So now I need to find Nitesh in the class. So if you observe that all the names are in the dictionary order, like B is first, then G, then GA, then GAY, GAJ is first, then GAY, then GOBI, then Hani, Harsh, Jyotirmaya, Kaustav, LJ, Mitali, Beddi, Polly, Sai, and the very last name is Vishu. So do I need to iterate over all of the elements? Do I need to iterate over all of the participant and find Nitish? Or I can use up this fact? Give me a quick yes or no. Is there any way I can find Nitish further other than iterating over all the folks one by one? Is there any way I can do fast? This is not binary search. We can take use of the dictionary order basically. Don't directly go to binary search. Let's just go slow by intuition. Okay, you shouldn't be rotting up that if it is sorted, do binary search. No, you should learn this first. Have the intuition of that. So this is binary search. So if I start from the top, if I start from the top, I see B. Then I would scroll a bit. I see K. So now I know that the value Nitish won't be before Kaustav. Now again scroll a bit and I find P. And I now know that before P, Nitish is not present. Okay, before this Nitish should be present. Sorry, before this Nitish should be present. So there is no point in going after Polly Anil. So I would go before it. Now I find this, just like we find a word in the dictionary. We do this. Now we would extract this intuition out there from real life and let's try to embed it to programming. Okay, basically algorithms, not really programming. So now see this. If we have two, okay, if we have the values as 2, then 4, then 6, then 8, then 10, then 12, then 14, then 16, then 18, then 20. Let's say these are all the values. Okay. If we do the indexing, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 10 elements are there and we need to search all the values. Okay. Now let's say that the value that needs to be searched is 8. Okay. The value that needs to be searched is 8 itself. Okay. So what I do is I start off with the entire dictionary. I say that initially I need to do the searching from L to the entire R, that is 9. So what I did was I scrolled a bit and then had in the middle. So what I would do, instead of scrolling in the middle, I would find the middle. Mid is equals to L plus R divided by 2. If we employ it here, it would be 0 plus 9 divided by 2. That would be 4.5. But let's take the value 4. That is the floor value of this, because indexes can never be in decimal. Okay. So we have the value as 4. Okay. So now we go to the value 4 and we start analyzing this 4. Okay. We start analyzing the element at index 4. What is that element? That element is 10. And what is the element that we are trying to find? We are trying to find that the element 8. Okay. So it would be present on which side? Understand this. It would be sorry. It would be present on which side? It would be present on this side or this side. See, this is not equal to 8. So which side it would be present? It would be present on this side, because the element that we are trying to find is smaller than the element that we are pointing to currently. So that is why we would go on focusing on this side. So now I would simply say, I would just write it down. If A of mid is less than the element we are finding, then what we need to do? We need to focus on this side. So earlier we were focusing on the entire 0 to 9, but now we should focus on this side only. Why? Because this is checked and going on this side is unnecessary. So this side is the side we should focus. How we can focus? L is already over here and R is over here. So why not take this R and keep it here? Please see it again. I would repeat that again. See, we are trying to find a value which is less than the value we are pointing, that is 10. So we should focus on this side. How to focus on this side? Earlier, we were focusing L on this side and R on this side. L on this side and R on this side. So L is already here. So if we want to shift this focus, why not keep this R over here? And now my focus would be this one. So that is why I would simply write that R is equal to mid minus 1. Okay. So now R is what? R is none other than 3. Again, let's do the same drill. 0 plus 3 divided by 2, which makes it 1.5. We would take the floor value of it, which is 1. Now we are pointing to this element. We are pointing to 4. Okay, we are pointing to 4 and L and R is currently here. We are pointing to 4 and the element we are trying to find is 8, which is greater than the element we are trying to find. Okay. Just give me a sec. I just need to close the door. Okay. Fair enough. So 0 plus 3 divided by 2 would make it 1, taking the floor value of it. And our focus is on this element. But we want to find an element which is greater than this element. So what is the scenario? The current scenario that we are standing right now is, if A of mid is greater than X. So what we should do? See, we have two options, to go on this side or to go on this side. We have two options because currently L and R is the part that we are focusing on. So if this is 4, then going on this side would have elements less than even 4. But we want to find elements which are greater than 4. So we should be going on this side. How we can go on this side? R is already here. We should take up this L and we should keep it here. That is basically mid plus 1. So we would take L is equal to mid plus 1. So we would take up this L, we would keep it over here. Okay. What is L and R? 2 and 3. So now 2 plus 3 divided by 2, which is equals to 5 divided by 2, which is the index 2. Now let us do an analysis over index 2. So we don't have any options over here because we don't have any elements, and this is not equal to 8. So the only option we have is to go on this side. And we are pointing on 6, which is less than 8. So element greater than 6 would be there on the right hand side. How we can go on the right hand side? We can take up this L and we can keep it to mid plus 1. Where we have written that? See here. If A of mid is less than X, then we go to R is equals to A of mid is less than the element. Sorry, we are trying to find. Okay, A of mid is the value to, yep. We need to go on. L is equals to mid plus 1. Sorry, L is equals to mid plus 1. Sorry. Sorry. So now, if we want to find an element which is on this side, because we know that the search space is only this, and currently we are pointing to 6, which is less than 8. So a value greater than this would be having here. So we need to make L go to this. So now we would make this L from here go to here. Now again let's do the same drill. 3 plus 3 divided by 2 is equals to 6 divided by 2 is 3 only. We go to 3 and check, do an analysis over that element. The element we are pointing is the desired element. So if A of mid is equal to the value X, then we return the value of mid. Okay. So let me just write it again. If A of mid is greater than, if A of mid is less than X, go to this. If A of mid, okay, I explained correctly, but wrote it wrongly. R is equals to mid minus 1. Sorry. Yep. Let me explain you how this is. So let's say we are trying to find the element 8. We are trying to find, let's say L is over here. Let's just remove L and R everywhere. Let me explain you these all small things which I have written. So let's say L is over here, R is over here. And the element we are pointing, is this element. Let's say. So this is 6. This is 6, and we should go to the right hand side to find the element greater than 6. So we should make L go to this side, that is mid plus 1. That is why I wrote, if A of mid is less than X, let's make L go to mid plus 1. Now let's do an analysis again. So let's say L and R is over here, and we are standing on this element, that is 14, and we want to find 8. So 8 would be present on the which side? Left hand side, because elements less than the current element we are pointing would be present on the left hand side. That is why we need to make R is equals to mid minus 1. That is what I have written. If A of mid is equal to the element, we return that the current value mid. Okay. So am I clear with this approach or not? Give me a quick yes or no. Okay, so during the start, the mid will be probably the mid of all the elements. Yep. Am I clear? Anyone has any doubts? Yep, sorry, I don't use PPT. So many times I explain correctly, but write wrong. That's the thing I'm not able to master even after 4 or 5 years of teaching. Sir couldn't understand how LNR is moving. Okay, let's do the dry run again, no issues. How can we find when the array is not sorted? There are two ways. You sort the array and apply binary search, or you use linear search. If the array is not sorted, you can't use binary search. This works on a sorted array only. LNR is basically not moving. Let us see this. See, let's say we have 2, 4, 6, 8, and 10. And the values are 0, 1, 2, 3, and 4. Okay. Initially, L and R is pointing to this. That is, L is equals to 0 and R is equals to 4. Okay. And let's say we are trying to find the element 8 again. X is equals to 8. So first, we would do 0 plus 4 divided by 2. What is the formula? L plus R divided by 2, the floor value of it. So 0 plus 4 divided by 2 would make it 2 only. So we would go to 2. And the element we are trying to find is 8. So element higher than 6 would be there on which side? Right hand side. So we would take this L and we would keep it over here. So that is why we are saying that if A of mid is less than X, L is equals to mid plus 1. See, mid plus 1, we keep it here. Okay. So now L and R is over here. That is 3 plus 4 divided by 2, which is 3.5 basically. So we would go to just 3. Now this is the element that we were trying to find. So this is how we can find. Okay. Let me write the code of it. What is the disadvantages of applying? Sir, what is the disadvantage of applying binary search on unsorted array in terms of complexity? Okay, we would talk about this. First, let us complete this discussion. Sir, if we are more than uncountable array, then we can. How we can find if the array is not in sorted order? Okay, okay, we would explain this. First, let us code binary search. The code of binary search would look something like this. Okay, so what we can do is we can write int binary search. I would use snake casing. And let's say I would have an integer with the size of the array as n, and I would have the element x. Okay, I hope I am visible. So initially int l is equals to 0 and r is equals to n minus 1. And we would keep doing that until l and r does not cross each other. So while l is less than equal to r. So first we would find the mid. Every time we would find the mid. So we would find L plus R divided by 2. We are doing integer division. So automatically the integer part would be taken out. So the floor thing we were doing is handled by the code itself. So int mid is equals to L plus R divided by 2. So we would just check if A of mid is less than X. Then make L is equals to mid plus 1. Okay. Else if A of mid is greater than X, if A of mid is greater than X, then R is equals to mid minus 1. Okay. Else, this is the scenario when A of mid is equal to the value X. This is the scenario because either it would be greater, either it would be less, or either it would be equal. There are only three scenarios. ज़्यादा हो सकता है, कम हो सकता है, या उसके equal हो सकता है. Okay. So now what we can do is we would return this index, that is mid. Okay. Else, if we are coming till this point, we would return -1 that the element is not present. So I would just do some formatting over this code, and this is the code. Let me just recheck it again. Int L is equals to 0, R is equals to n minus 1, in mid is equals to L plus R divided by 2. If A of mid is less than X, L is equals to mid plus 1. Okay. And mid minus 1 and return mid. That's pretty much sufficient. Okay, now the very first, am I clear with this code or not? Give me a quick yes or no. Give me a quick yes or no in the chat. Everyone? Okay, now Mm, how we can find when the array has not in the sorted order? So this is a very good problem statement. Okay, this is asked in interviews. Check if array is sorted or not. I would check if array is sorted or not. See, these there are problems. Okay, there are problems, and these type of problems are asked in many companies. Okay, many companies ask this. So let us learn about this problem also. Okay, you just need to check if an array is sorted or not. So what is the property of sorted? This element would be less than equal to the next element. This is the property. So now if I want to just check if the elements are sorted or not, what I can simply do is I can just employ a binary function over that bool check sorted, and I would take the same parameters and do pass by reference. Okay, and then I would say I would employ a for loop. I would just find the size of that first. For int n is equals to a dot size, and then what I would do is for int I is equals to 0, I is less than n minus 1 and I plus plus. Okay, let me explain you why did I do n minus 1. See, I would go to each element and I would check if it is less than equal to the next element or not. So see, if I go to the last element also, then checking the next element after last would give me an index out of bound. That is why I am going till the second last element. So I would just check if a of I is less than equal to a of I plus 1. Okay, if it is, then simply do it. If it is greater, then this is the point where it is not sorted. So I would return false. Okay, if the control of the program is reaching till this point. Okay, I would just copy this to have better formatting, better linting and all. I would just do the same thing over here. Okay, so now if the control of the program is reaching here, that means we didn't find any invalid condition. What is this? It's an invalid condition. So if the control of the program is reaching here, that means we didn't find an invalid condition. So at this point we would return 1. So this is how an array can be checked if it is sorted or not. First thing, why r is n plus equals to 1? Plus minus 1, where is r plus minus 1? Where is? I don't find any. Just tell me. Okay, why r is n minus 1? Okay. I would explain that. See, array indexing starts from 0 till n minus 1. That is why the first L would be here and R would be at the last index. So the last index is what? Last index is nth minus 1, nth minus 1. Okay, I would explain you. See, better explanation. See, if this is the size of the array, so see, this is the size of the array is 10. So the last element's index is what? 10 minus 1. Here also you would see the same thing. If the size of the array is 5, then the last element's index is 4. Okay. Okay. How we can have more than uncountable list, how many we can find extra. Just explain this a little better. So what is the disadvantage of doing binary search on an unsorted array in terms of time complexity? Let's handle this also. Okay, sir, if we did it for even number of elements, but if it is odd, then what will be the center? Don't worry, this code would work for even as well as odd elements. Okay, now let's just handle what is the time complexity of what is the problem if we use binary search on an unsorted array. See, binary search only works on a sorted array. So let's say you are given n elements. Let's say you are given an array of n elements. Okay, you are given an array of n elements. Okay, and it is unsorted. So what will you do? You would sort the array and you would use binary search. Sorting an array, if we use merge sort or quick sort, it would be n log n. Okay. And doing binary search, we didn't still explain what is the time complexity of binary search. Let us first discuss that. So I would tell you the explanation. See, there are three scenarios. There are three scenarios only. If this is L and R, okay, I would explain. Say, if this is L and R, first we are considering the entire array, then we are checking this element. There are three scenarios only. Either this would be the desired element, or either the desired element would be this side, either desired element would be this side. Matlab, what I wanted to explain is that either we would find that element or either we would decrease the search space. Translating the same in Hindi for better understanding is either जब एक बड़ा सा सर्च स्पेस लेके स्टार्ट करते हैं तो हर बार क्या होता है, आइदर वो बीच वाली एलिमेंट ही हमारी एलिमेंट होती है तो बाइनरी सर्च रुक जाएगी, अगर बीच वाली एलिमेंट हमारी एलिमेंट नहीं है तो क्या होता है, वो एरे का साइज डिवाइड बाय 2 हो जाता है, क्योंकि पहले इतना था, फिर इतना है, फिर इतना होगा, फिर इतना होगा, एंड में जाके ये हो जाता है. सो बेसिकली एट ईच पॉइंट ऑफ टाइम the search space is getting reduced by 2. Okay, and a number, so if there are 8 elements, then dividing it by 2, 4, 2, 1, so it would get divided by 2. So if you observe, this is none other than log base 2n. मतलब जितने बार divide होगा, what is the logarithmic tells us how many times this can be divided by 2. So log base 2n is the time complexity of binary search because every time the size gets divided by 2. So we don't write the base also. That is why the time complexity of binary search is termed as log n. So if we apply binary search on an unsorted array, it would be n log n plus log n. And so this we need to do. But if we do just linear search, it would be just big O of n. So big O of n is better than n log n plus log n. So that is why we use linear search if the array is unsorted. We use binary search if the array is sorted. But one more terms, if you are an intermediate, then only try to digest this explanation. For people who are not intermediate, they can skip this explanation. What is this? See, the thing is that if we need to search a lot, then this is acceptable. Why? Because the subsequent searching that element becomes easy. Here, every time if you don't sort it, every time you would be encountering a cost of n only. This is a one time operation. So अर्थात अगर आपको बार बार सर्च करना है तो एक बार सॉर्ट कर लो और बार बार सर्च करते रहो, तो क्या होगा, लॉग एन ही लगता रहेगा बाइनरी सर्च के लिए. बट अगर आपने सॉर्ट ही नहीं किया तो हर बार आपको लीनियर सर्च चलानी होगी, और तो आपको बार बार एन 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 का ऑपरेशन लगेगा. सो अगर आपको बहुत बार सर्चिंग करनी है, दैट इज इफ यू आर प्रेजेंटेड अ प्रॉब्लम विद अ लॉट ऑफ क्वेरीज, then do sorting and then do linear search subsequently. If if the array, if you want to search only once, then just do linear search right away. Okay, so that's pretty much the idea. Am I clear with what is binary search, and how can I cover the previous lectures? You can just go to the previous recording and see it. Okay, sir, give me a quick one if this thing is clear. I have a very large or uncountable array list. How can I find the middle and extract information? If you have a very large array, irrespective of the size, array would definitely have an index of it. So you can just find the size of it. So starting index plus last index divided by 2, you can just, irrespective of the size, you can access elements from the index by using index in constant amount of time. Okay. Anyone, this is an open forum now for the last 2 or 3 minutes. If anyone has any doubts, you can quickly ask me. Else, this would be a wrap up. So today I kind of had a very busy day. Woke up a little late, that is around 8 o'clock. I wake up around early. Then after waking up, I worked out a bit because next month I'm going to Goa, so I should be good enough. So then I had cooked my breakfast, and then it was a rush. Watched a movie, that Gran Turismo one. and then started teaching. So pretty much today it was fun sort of. Most of my weekends are like this only. Sir, एक बार odd number of elements का example elements का कर लीजिए ना. Okay, sure. That's my job. Let's do it. So let's say if we have 1, 2, 3, 4, 5, and the indexing are 0, 1, 2, 3, 4, 5. So let's say I want to find the elements for element 3. Let's say x is equals to 3. So L is equals to 0 and R is equals to 4. So mid would be equal to 0 plus 4 divided by 2 would make it 2. So we would go, okay, so let's say we want to find the element 4, not 3. So we would go to the index and we would see the nature of this element. We found out that the nature of this element is 3. So element greater than 3, because we are trying to find 4 and we are pointing to 3. So we need to go on which side? We need to go on the right hand side. So we would make L is equals to mid plus 1. So mid was 2. So L mid plus 1 would make it 3. So now 3 plus 4 divided by 2, which is equals to 7 divided by 2, which is equals to 3.5. We would take 3 and now we would land to the correct element. So even if we have odd elements also, we would definitely land it. No worries. You can just take the floor value of it. Sir, I'm a student of BCA third year and I'm not from a very big college or university. Can I give OS campus placement in 1 year? I I am from Netaji Subhash Engineering College. That's a small private college in Kolkata. And I started working at Geeks. I cracked Geeks for Geeks at the end of my first year. So if I can do it, anyone can do it. Because I'm not IIT JEE kind of guy. I'm a guy from Ashes. I'm not able to register my attendance, drop a mail to support at Geeks for Geeks, or you can just share it. So let me share my LinkedIn URL also. So this is my LinkedIn. What can you explain again? What you want me to explain? No, no, you don't need to. Sir, odd elements में I meant odd index, odd number index. No, no, odd index नहीं आएंगे basically. ऐसा इसलिए होगा क्योंकि क्योंकि बेसिकली दो एलिमेंट आए भी तो आप तो हमेशा फ्लोर वैल्यू ही ले रहे हो ना. That won't make a difference. So that was it from my side. If you have any more concern and queries, you can just drop your concern and queries in the LinkedIn. If you are a person who would like to explore, binary search formula after r is equals to mid minus 1. This is my Instagram. It's pretty much. So binary search formula r is equal to mid minus 1. Okay. This part? Okay. See. So let's say we have 1, 2, 3, 4, 5, 6, 7. L is over here, R is over here, and the element we are pointing is let's say 5. The mid is basically 5, suppose. And we want to find the element 2. So at this point, we need to focus on this side. To focus on this side, what we need to do, this is mid, this is R. So we need to take this R and keep it here. So this is the point of time where we do if the value. So if A of mid is greater than the value x, then we do r is equals to mid minus 1. That's the idea. Now am I clear? That is why I wrote over here if A of mid is greater than 1, r is equals to mid minus 1. I derived it again instead of explaining. Am I clear to you, LJ? Sorry, any assignment for the week? Yep. Which part I need to explain again? Am I clear to you, LJ? No issues. You can always join the class. Okay. So that was it from my side. Thank you and have a nice day. Goodbye, everyone.